So this is basically a talk on using OpenDataKit for OpenStreetMap. So at HOT, we use OpenDataKit incredibly heavily. And one of the problems we have is that we've been collecting data and getting it, changing all the tags and all that gunk and getting in the OSM is so tedious that it actually never happens. And it actually really pisses the hell out of me. So I decided to write software to make all the data flow processes kind of seamless. So I won't get into it so much for this particular talk, but also a lot of this stuff also designed to work fully offline, because usually if I'm in a disaster, I have no internet for a couple of weeks. And so a lot of the software also predates my working at HOT. So this has kind of been a long time project that I've turned into HOT stuff. So I map a lot of weird stuff. So here's my office. I spend a lot of time doing field data collection. Often for a week or two at a time. These days I go out for about a week or month. Obviously solar panels, and doing a lot of updating for emergency response access. But I also map a lot of gunk that's completely ridiculous. So I collect a lot of weird data. My primary purpose for a really long time is updating highway data and other stuff like that for emergency response, wildland fires, backcountry rescues. My day job, we collect data for humanitarian purposes and stuff like that. And sometimes, a lot of times when I'm way out, I'm mapping campsites and climbing area trails and just weird gunk and kind of fun stuff. So here's kind of some of the gunk I've mapped. On fires, I have to map, where can I get water? You know, it's kind of important. You can't do this in organic maps, right? And so this is where OpenDataKit is nice. I can have a custom form for where I can get water. Helicopter landing zones is another one. Incline's important. Helicopters want less than 10-degree slope. A lot of highway mapping, which we use in Colorado for wildland firefighting, which is kind of a classic. A lot of times when I'm way out, I find these historic cemeteries that are 100 years old, kind of fun. None of them in OpenStreetMap, but I add them because I think it's kind of interesting. A lot of cool ghost towns in Colorado, which is kind of fun. None of the stuff you can map in any of the other apps. If you look hard, you'll see my truck camping. This is really another good spot. So I map a lot of campsites. I've probably added hundreds and hundreds to the map in Colorado. Plumbing was a really good project. So this is the Uray Ice Park, and I mapped all the plumbing. The fun of this project was 2 weeks after I took this picture, a landslide wiped out half the plumbing. And when the insurance company found out I had maps, they were incredibly happy. And hot springs, I mapped hot springs in Bhutan. That was a really fun trip too. So what is OpenDataKit? So basically it's customizable collection forms. Like when you use like organic maps or JOSM or whatever, you know, you've got presets. So think about OpenDataKit kind of lets you create your own presets, I guess is how I kind of think about it. One of the other nice things about OpenDataKit is that it's used by probably at least 24 apps that I'm aware of, some commercial, some open source. So it's kind of I would say, industry adopted format, and we really like it. It uses a spreadsheet as kind of the editing of the source files, which I find totally perverted, but that's just the way it is. Someday I'm going to write a program to fix that. This particular workshop covers some functionality that is only in ODK Collect. And some of this is sort of based on what used to be an OpenMapKit, which is now a dead project. Kobo Toolbox does not support some of this functionality, so I'm not slacking on them. I'm just saying that they have yet to add that support. Whether they do or not, I don't know. Maybe someday I'll get to support them. Terminology-wise, for those who aren't in OpenDataKit, you'll hear this a bunch. An XLS form is the source file in the spreadsheet. The X form is the output after it's been transferred into the form that I can load on my phone. So basically, like, why use OpenDataKit, right? It's actively supported. I can complain. They add features for me. They fix bugs. It's like really, really nice having that right there. I can also edit existing data now using ODK Collect, which is really, really awesome. So I can actually edit OpenStreetMap data, which I'll be getting into, and stuff like that. And it's really, really focused on custom data models. Like a lot of times at HOT, we're mapping waste disposal. Try mapping waste disposal in organic maps. I like organic maps, by the way. I'm not dissing on it. It's focused for a different user group. And that ability to do the custom data models is why we really like it. The other nice thing is it supports imagery-based maps. So when I'm in areas, even in Colorado, the map data on Google or OpenStreetMap may be lacking. And so having a satellite imagery, like I'm standing in front of a building that's not on the map, but I can see the building, you know, in satellite imagery. And it's kind of a nice way to fill in the gaps when I'm out in the field, typically by myself, really far away. And then a lot of this project is also focused on really fast data entry. For the 3 people that know OpenDataKit, a lot of XLS forms are incredibly inefficient. 1 question per page. Oh, I've got all the data for anything I'd want about a building. So I'm mapping healthcare facility, but it's asking what the cuisine of the restaurant is. And so part of this project was designing really highly efficient forms using some pretty much of the advanced functionality of XLS forms. And then we've created an entire library of about 24 forms focused on humanitarian data collection, so that now every mapping project we do typically has their own idea data models, but by giving them a template of the data model that HOT and World Bank and other people we work with is kind of defined on, it gives them something to build on really fast. We're actually deploying this project in Rwanda next week, so I'll find out how easy it is for other people to edit my templates, because it's the first time I'm handing it off to somebody else and monitoring instead of doing all the work myself. So a lot of this project is really into super efficient forms. Like I'm trying to map all the amenities in a small town. I want it to go really, really fast. Mostly because people get weird when they see you mapping and like, why are you stopping at every building and typing on your phone? I get accosted a lot mapping in Colorado even. I'm only mentioning OpenMapKit because a lot of people think this is a great project. It was. It doesn't work anymore. It doesn't even compile. And after Android 10, it won't even launch. But there's a lot of great functionality in the OpenMapKit, so I don't want to dump on it. But over the last few years, all of its key functionality has been migrated into OpenDataKit. And so we can let OpenMapKit kind of die a nice death and thank it for its years of service. It did have a great server side. So what is this project? So a lot of this project was really efficient XLS forms, so that when I've got a bunch of beginners, I give them their couple of hour training class in like Zanzibar, they can go out and map efficiently and easily and not get overly confused. It's a whole library of forms for a lot of obviously humanitarian stuff, although I've got a great form for camping and things like that. It works fully offline, which is another important thing. You can't always expect to have a cell phone connectivity, imagery-based maps. This project also makes extracts from OSM that you can then load into ODK Collect, which I'll get into, so that you can actually edit existing data from OpenStreetMap in ODK Collect. Because when we've done remote mapping, we have building equals yes. Well, but this building is a restaurant, this building is a residence, this building is a hospital. The cool thing about editing open data is rather than standing there waiting for your GPS to get 3 satellites, you've already got the location and the existing data. So when I touch the entry in ODK Collect, it's like really, really fast. So I've already got my location. I can add the few tags. This building is a restaurant that serves Mexican food, and keep walking before the locals wonder what I'm doing in their small town. I've definitely had problems in small towns in Colorado. It has some other weird stuff, like when I'm working on data models, I can search through tag info to see the frequency of various tagging. So one of our data model guys at HOT has a bunch of cool values that seem really important. I'm like, dude, this tag value is used 4 times on the planet in 15 years. I don't think it should be part of the data model. I've been able to use this to sort of use the more common tagging rather than like the overly detailed tagging that's perfect, but almost never used, never rendered, and kind of useless unless you're doing deep SQL queries. It's also, funny enough, designed to be part of a fast API backend. So this whole project is the backend for the Field Mapping Tasking Manager project that I talked about on Friday. Actually, this predates that project, but when the guy for FMTM found out about this project, he's like, oh, that's the part that they needed. So yeah, it works standalone, works offline. It also works for fancy websites if you have this thing called internet connectivity. And pretty much everything in here is based on a boundary, right? So a lot of us have a lot of data, especially when I'm working in the field. And so, I mean, like I have sat imagery for Colorado on my laptop. And so everything, you give it basically an AOI. So I'm doing my data extras, I'm doing my base maps. Pretty much, I want to have a lot of data with me, but I want to do subsets for my specific interest and area that I'm working. Because a lot of times you can't download stuff you want. For anybody here who's interested, basically, it's a Python project, so you can install it from PyPI. You can also get it from GitHub and all that kinds of stuff like that. One of the reasons that I can plug in the fast API is it uses classes and methods. There's a lot of Python programming I've seen that is very procedural and doesn't like object-oriented programming that I kind of do. And as I said, it's part of the backend for the Field Mapping Tasking Manager project. This does all the data processing for that other project, which is huge too. So one of the things was, I said, efficient mapper data flow, support for editing existing data sets, sometimes external data sets. Like the other day I was out mapping, I had a data extract of BLM campsites in Colorado, and I could use that as targets to go edit and improve that data and import into OSM. I like mapping campsites. And also a lot of this was designed to make the data we collect easily imported into OpenStreetMap, because a lot of times when people are doing XLS forms, they're just, arbitrary values and tags and stuff like that. Part of the other thing, I'm not a fan of one question per page, although have had people tell me they prefer that. I don't know why. So like if I'm mapping a building, I like my 4 or 5 building questions on the same screen. To me, that seems efficient. Here's a building, it's a restaurant, it's made of brick, it's got a metal roof, next building. And I use a lot of the advanced functionality, choice filters and conditionals and triggers and a lot of stuff that took me a while to figure out even as an engineer. So a lot of this software started a year ago. When I was doing my initial improvements to XLS forms, one of our engineers, Kristen, who stands out in the middle, spent several months in Stonetown, Zanzibar, working with youth mappers, and it was great. They would go out map for a day, they'd give me all the bug reports, and I would go clean up stuff, and then they could go out a few days later and try it again. So we used this to sort of start fine-tuning what I thought was efficient for me is not necessarily efficient for some college kid in Zanzibar. And so they were super, super helpful in the early stages of this project to kind of fine tune stuff for normal people. And they're also adding Somali translations to a lot of the apps for us, which has been really nice because I'm a huge fan of translations. In addition, for the work tie-in, Hot's got a whole bunch of data models we've developed. I've been finding out that nobody actually wants to use our data models, but they have usually huge overlap with people's preferred data models. And so once again, our data models are our templates, then people can grab those, enhance those, edit those, and improve them. So hopefully then taking advantage of the advanced functionality and not having to learn it, but adding a few of the survey questions that they might want for their specific thing. And we have some weird forms like building condition. Is this building still standing or the walls cracked? We collect weird stuff. So for the non-OpenDataKit people, you can sleep for this part. Basically, it's a spreadsheet and it has 3 sheets. So there's a survey sheet, which is have all your questions. And there's a choices sheet, which is all your values. And then there's a settings sheet, which we don't really care about. So the important thing for the 3 people that understand this is the column that's titled name, when you convert it, becomes the OSM tag name. And when you go to the choices sheet, what's in the name field there becomes the OSM value. So if in your XLS form, your name for something like highway and your value is path, there's nothing to convert. It just goes right into OSM, so it becomes really easy. Not everything is that easy, but we try to do that as much as possible. So the XLS form library actually many of the survey questions actually have the OSM tag, don't need to be converted, and it just works out of the box. Sometimes a certain survey question may actually generate multiple OSM tags, power source generator, manually operated, stuff like that. There's another field that's kind of complicated called calculations. Calculations is how we edit existing OSM data. I'll get into that in a minute. There's a thing called a trigger field, which if you forget to add it, your data never updates, but I'll have some examples of that in a couple of minutes. And so what we do is when we load in an OSM data extract, when I select that existing feature, it populates all the defaults for the form. So if it's got, sometimes I was mapping in a Tamal, Kathmandu a month ago, and some of the buildings had 15 tags already. Opening hours, Wi-Fi access, password for the Wi-Fi, like huge amounts of junk like that. It's kind of nice, but I can pull out the few tags that I wanted for my XLS form, and then later I can conflate it with the OSM tags, so you kind of get everything. But sometimes things have changed, right? Like if I'm mapping an amenity in Colorado, a lot of the small towns in Colorado, the restaurants closed, and now they have new ones. So I can load the existing OSM data, change the name of the restaurant and what the cuisine is, and update it. It works out pretty well that way. And I'm also a big fan of grouping. So a lot of times I like to group questions. Like here's the 5 questions I want for this type of building data. Here's another page that's got those questions, and I try to group them in kind of a related functionality. So the thing that was the big deal was last year about this time, OpenDataKit added the ability to load a GeoJSON file with GPS coordinates in it and edit it. This was kind of what launched this last stage of this project. This is not supported by Kobo Toolbox yet. If they ever support it, then we'll support them. But right now, ODK Collect is the only one that does this. And this is great. So I make a data extract, generate a GeoJSON file, and there it works. Once again, the extract is based on the AOI of where I want to be collecting data. So making the data extract turned out to be more complicated than I would have thought in the beginning. Sometimes I'm making a data extract from other sources, but in the OSM world, this software makes a data extract from local Postgres database. I may be out in the field. I've got all of Colorado loaded on my laptop in Postgres, and so I want to pull out an extract for like this national monument, for example, that I'm working in. You could use Overpass if you're online, and you can also use Hot maintains a Postgres database of the planet. So you can also query that for data extracts. It's a little finicky in that your output file has to have an ID, title, and label in the GeoJSON file for ODK Collect. So when we make a data extract, it basically looks at like the name field, and the ID is actually the OSM ID, which I propagate through this whole line, which I need for conflation. The problem is if your data contains a value that is not in your choices sheet, ODK Collect won't launch. And so you actually have to filter out all of the tags that may be in the data extract that you aren't really that interested in. And so I wound up having to write a program for that. So there's a program as part of this project. Obviously, you make data extract. And right now it's using the Underpass database at Hot that we maintain. And it's pretty much I can do, full SQL queries, which is really, really sweet. I hate Overpass sometimes. And the nice thing is that Underpass works really, really well. And obviously when we're using this for the FMTM project, we're making data extracts all over the place. And it's nice not having to teach people Overpass query language, which is really weird. Underpass is updated every minute and stuff like that. This project also supports, Overpass. It's just not quite as detailed, unfortunately. So here's the program. It's pretty simple. As you can see, you can specify Postgres, Overpass, output files, input files, DB name, all that kind of junk. It lists a bunch of categories. Each one of those plugs into the XLS form library. There's actually more categories now, but they wouldn't fit on the screen. And ultimately, it will keep getting extended. So here's a couple of simple examples. The first one is, I'm out camping, and so I want to pull all the campsites in Flat Tops Wilderness, where I'll be next week, from Postgres running on my laptop because I'm sitting in the woods. Maybe I'm working on, Langtang Village in Nepal post-earthquake, so now I'm using Underpass because I have an internet connection, and so I'm making that building extract that way. The idea is that you want to make an extract from multiple input sources. So here's where it gets more fun. So basically, select one from file, camping.geojson. The name becomes the reference for everything else. And so, so basically tourism, I'm mapping campsites, right? So in this case, I only have my two values in my choices sheet. And so basically, here's the key detail under the calculation field. And this is really ugly, but basically that will pull the fee. So I got a bug in my slide. Should be tourism. But anyway, so basically this goes through camping is the name of the file. It takes the base name from the GeoJSON file, and that's my instance name. It uses XPath, and so all this kind of junk existing references the camping file. And then the last thing, fee, which actually be tourism, is the actual value from the data extract that I want to use. And then the trigger in this case is existing, so that if it will update the value if it changes and stuff like that. If you don't do that, it won't populate ODK Collect. Then the other fun stuff is that sometimes I have a value that I want to reference multiple times. So then in this case, is I can have a calculate field, and I can basically, it'll store the XID, in this case, the location, and I can reference it multiple times in the XLS forms, which makes it a lot easier. Like some stuff like the tourism field, I can have that instance on the survey question and it's easy. But sometimes I want to have, XID in multiple places and all that kind of stuff. And so here I can kind of preload those variables and then reference them later. So the other fun part was name conflicts. I think I'm the first person to ever use the select one from file functionality. So it turned out to be interestingly, I won't say buggy, but it was interesting. XPath is slightly brain dead. The base name of the file becomes actually an XPath node. So if I say camping.geojson, then I can't use camping as a value anywhere because it'll conflict. It gets kind of bizarre. In the name field, you can't use colons. So I convert everything to underbars. For, in this case, select one type, I'm using building material because building material matches exactly what's in the OSM data extract. And you'll see why in just a minute. And so basically, this works out reasonably well. So, building material is going to go reference into the choices sheet. The name that theoretically the OSM tag name is going to be building material with an underbar, which I convert back later. And there's a reason for this. So when I'm filtering stuff, as I said, if there's a value in the data extract that's not in your choices values, it's going to blow up in your face. And it took me a while to figure out why it would launch. And it turned out this was the kind of key detail. So because you can't have a colon in the name field, I can't just like, oh, do I direct conversion? And so that's where we'll get into, there's a conversion thing that says, oh, the name field's got it on their bar, actually it should be a colon, things like that. The filter program is fun. So what it does is it scans the choices values in my XLS form sheet and deletes anything not in the existing choices. So if somebody said highway equals, I don't know, sidewalk or something, you know, and I'm not trying to collect sidewalks because there's none in Nigeria, then it just filters out anything highway equals sidewalk. And so now what happens is the data extract only has the values that exist within my choices sheet of the XLS form. This is actually kind of a key detail that drove me nuts for a while till I figured it out. And then the other fun part is the same program that I use will then also filter my data models through tag info. So once again, so my wonderful data model people stop using tag values that are only used like 5 times on the planet in 15 years, just because it's really detailed. And sometimes that's kind of a silly thing. Yeah, tag info is great. You can download the database on your computer. It's awesome. So this program basically parses the XLS form, extracts all the choices, and then produces a new data extract. And it's also then modified so I can easily conflate it later, because conflation is kind of the key detail. This program also has an ODK Central client. This actually predates the one that the OpenDataKit team wrote. And so ODK Central is the server side of OpenDataKit. It's where you download your forms from. It's where you upload the data you collect from and all that kind of stuff. And so when I found out that Central had a REST API, I'm like, oh, this is great. So I wrote this client program for it to basically update my forms and download my data extracts and do all the manipulation. Right now, there is a PY ODK program developed by the ODK developers themselves that's pretty good. My program predates theirs, so I didn't use it. I had to apologize to the developers. And then once again, this is a key. I don't use this when I'm offline because obviously I can't talk to the server, but the Field Mapping Tasking Manager project uses this really, really, really heavily. The last line is important. It's got a really crude command line interface because it's basically the back end of a fancy website. But I'm looking for volunteer contributions, improving the command line interface. Someday somebody will actually fix all this stuff. It's pretty ugly. So right here, classically, right? So I want to download submissions. The submissions, for those who aren't in the OpenDataKit, is a submission is basically what I've uploaded to ODK Central that I've been collecting. So this project, I'll run my little client and say, give me all the projects on your server side. It's got a config file that I use and things like that. So once I get the project number, in this case 56, I'm like, okay, give me all the water points I collected for project 56 as a JSON file. ODK Central also exports a CSV file, but it turns out it loses data for complicated XLS forms. So I primarily use the JSON format because it actually is much more complete, like repeats. The CSV files don't handle repeats very well. It makes a whole subdirectory of little files. It's a pain in the ass. And then this also said basically does all the work I do with the ODK Central website. And you can use PyODK on your own, but as I said, we don't use it. Here's where it gets more fun. So when I've downloaded the output, the submission, I have 2 different programs. The older program, CSV dump, takes a CSV file input as a file, and then it generates the output files. The newer program, the JSON to OSML, generates it. So what it does is, especially for humanitarian purposes, we're often mapping data, not all of which is appropriate to OpenStreetMap. Maybe I'm mapping waste disposal, and one of the questions is like, what is the age of the person who takes the garbage to the dump? I kid you not. And so I don't really care about the age of the mapper. That's not for OSM. The World Bank may actually care whether all the teenagers taking the trash to the dump or the grandparents. And so people that fund our projects want all the data, but OSM only wants a subset of it. So one of the other things this project does is it filters the data into kind of a private and public file so that what's in OSM is easy. You don't have to think about it. And then obviously the GeoJSON file is everything. So when I give it to the World Bank, they can do whatever they want. And that's turned out to be a really good mix. And then it generates also an OSM XML file. This is a kind of another key detail because I need to conflate it later. And it turns out that the only way I can conflate with existing data is in OSM XML format. I'll explain why in a couple minutes. So basically it uses a YAML-based config file for all the translations. Obviously, this is a subset of the whole file. So anything in the convert section is, just convert this straight. So a lot of times I'll have a file in the JSON file, something latitude. Well, obviously the attribute in OSM XML is lat long, altitude ELE. So this is kind of the simple. When I see longitude in the submission file, I just change the values. This is all pretty plus and minus, pretty simple. And then there's another section, private. So once again, income, age, education is a private data field. They can get really, really fun. So for instance, here I'm mapping coffee shops. Well, an amenity for a coffee shop may actually have multiple output tags. And then you'll notice in here, in this case, the equal sign basically says, so if I say amenity equals coffee for my submission form, it's going to say amenity equals cafe, cuisine equals coffee shop, and it breaks all that into the OSM XML file. So that works pretty good. And some other stuff. So the other one, the fancier one, cemetery services. So if it may have a value of either cemetery or cremation, which I can then change to those other multiple tags. So this handles pretty much almost everything we've actually come across. It's pretty flexible. Usually when I'm converting a form for the first time, I wind up running it a half dozen times and finding the stuff that I missed, and I tweak the YAML file, and within usually 5 or 10 minutes, I've got a perfect conversion going on. And then within the template, I don't have to edit these all the time, but if you're building on top of the templates, you would wind up adjusting this form to meet with the additional survey questions that you add. And then the other one last is multiple, because you can actually select multiple entries in a survey question. So this says the conversion software, this have multiple entries. Rather than looking for like spaces or commas in the data submission, it's just easier to specify. Healthcare may actually have healthcare equals emergency room, pharmacy, and maternity clinic or something like that. And so that way I can pull out the multiple things, and each one of those will turn into a separate OSM tag in the output file. Once again, I'm really into working fully offline. Remember this slide? So this is where the files live. So you can actually, when I'm in the field, I may be out mapping and say, oh man, I need to add this choice to my choices sheet because I keep seeing it all day long. I can edit it on my laptop over USB cable. I'm a big fan of the ADB debugging interface on your phone. I can tell you how to enable it if you want. And so I can basically copy my modified X form right to my phone. And the next time when I go out mapping, I've got a new choice and life is good. It works out really good. I can actually pull the instance files off, which turns out to be the best conversion format, right off my phone. So I don't have ODK Central. I can't download a submission, right? But I may want to grab the data I collected all day and clean it up at night. Your phone is typically 5 to 9 meters off. And so a lot of times I'm mapping stuff, and when I load it into my laptop, the GPS location's over there, but I actually want it to be over here. And so a lot of times what I'll do is at night when I'm in the field, I whip out my laptop, pull it off my phone, convert it to OSM, load it into JASM. I run my own tile server on my laptop with satellite imagery for my whole state in about 7 or 8 countries. And I can adjust all my locations based on the sat imagery to where it's supposed to be. A classic example, I'm mapping campsites on some obscure road, and there's a bunch of guys with an RV drinking beer with a lot of guns. I don't want to walk into their campsite to get a better location, so I'll just map where it is, where I'm standing on the trail, and get the hell out of there as quickly as possible. And then at night, I'll readjust it to where all the rednecks were. Not insulting rednecks, by the way, but you have to deal with some weird people when you're way out in the field, even in Colorado. And then the other side, I can update the forms every day. And so usually after about a week, I really fine tune my XLS forms really closely based on the reality of what I'm mapping. And that's kind of really, really, really useful. One of the funny things was we do a lot of mapping a building condition after earthquakes. I improved the XLS form by mapping archaeological ruins and national monuments in Utah and Colorado because, it's a building and it's ruined and it's made of adobe or it's made of stone. It was actually a really fun way to test the data entry and have a little bit of fun getting out of the office. So this is another one. This is the program that will actually take it right off your phone. It'll actually read the XML-based instance file and convert it directly to OSM XML format for JASM. Once again, it works actually better pulling the instance file off because you have all the data. And you don't have to worry about what Central is changing or submitting or whatever they do. So this is super, super, super useful. And so offline, this is the program that you would use. The nice part is, as I said, I can literally convert all the data files, update it. Then I can update what's on my phone, or like when I'm working like on a wildland fire. I can update everybody else's phones with the data we collected yesterday, because I'm mapping things like helicopter landing zones that are here for 2 weeks, which is where I get my supplies. Here's where the big tanker truck is parked, where there's diesel fuel. I do a lot of weird emergency mapping on wildland fires. And so this program is great because it lets me update the data that everybody else is using. So, we'll do the morning briefing. I'll have everybody bring up their phone while I'm finishing my coffee, bang, 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 copy it to their phones unless they're on iPhones, and then we're out of luck. And it's pretty useful. There's the other version. This one also then converts it to the CSV format, the ODK Central exports. This is the original program. And then once again, I can use the other program to go from CSV to this. I don't use it. I've kind of gone mostly with the JSON version primarily these days because it has all the data. The CSV file, as I said, is having issues. I'm not sure if this is being actively maintained now that there's the JSON format. Whoops. And then, it's the same thing. It just copies it right off your phone. So conflation gets to be the fun part because this is where all the time goes. And so if you've done good, like you've got, highway equals path in your submission or your JSON file, it's easy. You don't even have to convert anything like that. But sometimes it gets a lot more interesting. So maybe I'm out mapping somewhere and all I've got in this entire village in Colorado is building equals yes. And I'm standing in front of the restaurant or the hardware store or whatever. And I've selected the actual building centroid in ODK Collect. And so I've got the location. I have building equals yes, but I'm adding, well, it's a restaurant. They serve Mexican food and here's the opening hours. And so I want to merge what I've collected tags into the same, into the existing data. And because the OSM ID is propagated through this whole chain, it actually works out pretty good because that way I can reference using the OSM ID, I can reference the existing data and say that it's been modified. And this actually turns out to be kind of the trick, which is that if you increment the version number and you add modified in the attributes of the OSM XML file and you load it in the JOSM, it's really happy. And the cool part is that since I'm often mapping a centroid, I don't have all the rest for a building way. But when I load it in the JOSM, if it says modified, so if I go in the JOSM and I do file update modified, it pulls all the reps in. And then I have a perfect geometry and it works out surprisingly well. And then I can basically do quick validation, make sure that there's no weird tags that escape the conversion process, and then upload it. Once again, validating the data is kind of important. So a lot of times what I'll do is I'll load the data I've collected in the JOSM. I'll do select all, and then I just look through all the weird tags to see if I missed anything, to see if I skipped it. And if I did, I can either just say, okay, I'm just going to edit this in JOSM because it's easy, or delete it. Or I can go back and improve the XML, the YAML file, and then reconvert it again, and then reconflate it again, and kind of get it all perfectly seamless without a whole lot of intervention. And then once again, a lot of times you want to validate off of imagery, right? Because sometimes, as I said, the location you collect on your phone may be pretty, 5 meters is like the other side of that other table. That's pretty far off. Sometimes you actually want more accurate data. Like if I'm mapping a water point, sometimes you can't find the water point if it's that far away because it's behind the bush. So you actually having a better accurate location is kind of important. So a lot of times that's what I'll do. I'll collect that all day. At night, I'll open up a beer, load it, fire up the laptop, and then correct it off a satellite imagery while it's all fresh in my head. You can't do that a week later too good, but you can do it pretty easily that night. And if I'm camping by myself, I got nothing else to do. So here's the program that does the conflation. And basically what it does is it conflates everything, and then it uses the data extract that I use for the actual for ODK Collect as well. And then it will generate the OSM XML file that said, once again, I load this from the JOSM, it's done everything. I just make a quick validation and I can upload it. And the last couple of times I've been testing this in the field, I've been able to collect data for a week and clean it up and get it into OSM in about 15 minutes, which is an order of magnitude faster than what we've been doing in the past. It's before I had all this working, I'm the same thing. You collect all this data. Now I'm starting to go back through all my old historical data I collected that I never uploaded. And once again, it runs on a boundary because you may have a big data file, but maybe you only want to work on a little piece of it, and things like that. Pretty much all these programs use an AOI to filter data. Slightly separate image-based maps. So I'm a huge fan of imagery-based maps, or in the US, topographical map-based maps. So once again, you give it an AOI, and I want to post the extract and load it in the ODK Central. or ODK Collect. ODK Collect uses an NB-tiles format, so it's pretty simple. Also, I can generate SQLite DB file for Osman because sometimes you have to navigate somewhere before you can start collecting the data. And so this basically, this program is, you have to be online, but a lot of times I'm working offline. So I have my sat imagery for Colorado, but I'm mapping Humanitarian National Monument. I can just take the National Monument boundary, make my satellite imagery base map of just that little area that I'm in and load it onto my phone. Because you don't want to load the entire state of satellite imagery. Your phone would actually not fit. And it's especially great in really poorly mapped areas. And believe it or not, even in the United States, there's a lot of really poorly mapped areas. Even 5 miles from my house, there's areas that don't exist in anybody's map, so I actually bothered to add them. And once again, the base maps are really useful for selecting the location so I don't piss off the rednecks. And they're actually a problem field data collecting in Colorado. So this program, once again, makes base maps. FMTM does this as well. You can have multiple sources. OAM is Open Aerial Map. We use this a lot for disasters. So one of the classics was right after the Turkey earthquake hit, we got the post-earthquake imagery. And so I made imagery base maps of post-earthquake imagery for everybody that was responding so they could actually see what it looks like now versus what it looked like before. And that worked out really, really well because it's all based on drone imagery. So it's actually super accurate, super detailed, and really awesome. Once again, topo maps. I can use Esri data. I can use Bing. I can use Google Hybrid. You know, it's anything with a TMS link I can basically use for making my imagery base maps and stuff. And topo map base maps are also super, super useful, especially if you're just plain navigating. The cool thing is it makes base maps for Osman as well as ODK Collect, because a lot of times I'm doing navigation mixed with data collection and stuff. And there's only one other tool I know of on the planet that makes Osman base maps called Mobile Atlas. And so I thought that getting it working in here was kind of important. I don't know about you guys, but I'm a huge Osman fan. So unfortunately, their talk is right now. Oh, cool. The links are broken. All right. So last slide. This is actually editing XLS forms in the back of my truck, working in the field offline. You got to do something at night when you're camping by yourself.